Okay, this is the second video in this for loop exercise. And the point of this video is to look at nested for loops, which typically give a lot of students trouble. And the way that I like to explain this is the idea that one thing has to finish before another thing can happen. So let's say I were to draw a clock. Well, you have your typical analog clock, and you have your hour hand, and let's say you have your minute hand. Now what's happening is that your minute hand has to go around the entire clock, all 60 minutes, and once it completes those 60 minutes, once we're here, what happens to the hour hand? It is now moved to 1. So the minute hand has to finish rotating before the hour hand is on, or move before the hour hand moves to the next hour. So the hour hand is just hanging out. It is always 12 o'clock with some minutes until the minutes finish. Again, if you look at an analog or a digital clock, you might have 12:01, etc., 12:58, 12:59. We see that the minutes are changing with each increment. But then once the minutes are approaching the end of their count from 0 to 59, we will then be back at 0 minutes, but our hours have gone up as well. And then we'll repeat 1 hour and 1 minute, 1 hour and 2 minutes, etc. until we get to 1:59, and then the hours will jump up to 2, and the minutes will start over. And that's kind of the idea of a nested for loop. So if I have a nested for loop for x is equal to 1 to 3, and inside of that for loop, I will have another one that is nested inside of it. So I'll do that in a different color. Let's say I do that for y is equal to 4 to 5, and you know what I'll do? I will display in here, I'll display what x is, and I'll display what y is. So you can get a feel for what's happening. So when we enter this overall for loop at the top, the first value of x is what? Well, it's 1. That's based on the list. This is the starting number is 1. And then we'll come in and we'll start the next for loop, which goes from 4 to 5. This loop has to finish in its entirety over and over again. It has to finish before we hit this end. Because once we hit the black end at the bottom, now we'll come back up and change the value of x, which in this case become 2. Then we will repeat this again and again, depending on the number of numbers in the list. In this case, it's only 2, but let's assume it's 1,000,000. This will just keep repeating, keep repeating, keep repeating. And then we'll come down to this end. We'll come back up, change the value of x. So let's see what this code looks like when we look at a table of values, x and y, where when we start at the top, x is equal to 1. And then we come into the blue one, we know that y starts at 4. So what I go ahead and do is draw my command window. I'll probably have to draw this a little bit bigger. Here's my command window in MATLAB. There's my arrows. And when I start the code, we'll come in, we'll make x1 and y4, and we'll display those. We'll display a 1, and then we'll display a 4. Based on what we just said, we know that after we display, we hit this end, we have to come back up and change the value of that variable, which in this case is y. So that means that y will become 5. But what is x still? Well, considering that we've only been changing this blue one, the outer for loop, that's in black, will not change its x value. It will stay at 1 for the entirety of the time the blue one is running. So if we were to do this code now, we'll display 1, and then it'll display the new value of y, which is 5. At this point, this list is done, because remember, if I have no increment set, MATLAB assumes an increment of 1. So if I do 1:3, that is a list. That is 1, 2, 3. This list here is 4, 5. Again, you have an increment of 1 if it's not specified. So we have just gone through this first for loop case where y is 4. We now hit the end at the bottom. We jump back up. X now will go to the next value in the list. So originally it was 1, and now we'll move to the next value in the list. So x becomes 2. Okay. Now x is 2. We come here again. We're at this blue line now. What happens? Well, the for loop in the inside starts over again. So y will become 4. So we'll display x and we'll display y. If we go again, we know that this needs to finish. So it'll come back up and make y equal to 5. What is x? Well, again, x hasn't changed because we haven't come back to the top of the loop yet, the top of the outer loop. We're still inside with the blue loop. This will end up being 2 still. So what we'll see is we'll see 2 and then 5. Our last iteration will be we come back up, we make x equal to 3, and now we start the blue one again. So y will be 4. So this will be 3, 4. And then y will go to 5, and it'll be 3, 5. At this point, now that we finished the blue one, we come to here. And if we were to look at the top, we've run out of numbers in our list. So at that point, the code is over. And this is what would output. This is x, y, and it's just alternating x, y, x, y. Let's go ahead and show an example of this. Let me stop sharing my screen on my iPad. Let me go ahead and share my screen on the computer. Let's go ahead, share the screen. Oh, I feel like I shared the wrong one. 2 seconds, sorry. I'll share this one, there we go, better. And let's say I want to illustrate this concept, but with hours and seconds, or hours and minutes like we just did before. Let's say I do a for loop, where hours go from 1 to 12. Again, this is a list of 1, 2, 3, all the way to 12 in increments of 1. And I would do 4 seconds is equal to 1 to 60. 1, 2, 3. You know what I'm going to do actually to be more like real time? We'll start at 0 and go to 59. 0 minutes, 1 minute, 2 minutes, 58, 59 minutes. And then when you were to hit 60 minutes, that's really the same as starting back over at 0. You don't see a clock that's like 160. You would just see instead 2 o'clock. Let's go ahead and display. We'll do a F for F actually. We'll say that the hours are equal to, and I will just go ahead and use the hours so we can visualize that. And then I will do the same thing with the like that. So let's explain what this fprnf is doing. Remember, for fprnf, there is an input that we didn't type in. That is a 1. That basically says the MATLAB printed in the command window. If you leave it blank, its default is that. This is the text we want to show in the command window, where when you do a percent followed by a letter, the ones that we're talking about in class are I or F. If you do percent I, that means an integer. And whenever you see a percent followed by something, that's going to tell MATLAB to go look at what you have in the next section of this statement, where the variable value, which is hours in this case, which is going to go from 1 to 12, will fill in the blank there, the percent I. And this \n creates a new line so that this can be nice and organized. And the same thing is here, where we see I have seconds is equal to an integer, where the value of that integer will be the variable seconds. And I'll pause it for, I don't know, 0.2 seconds, so I don't need to wait as long. And then I'll pause it here for a good amount of time so that we can visualize what's happening. So here's the command window down here. Let me zoom out of this a little bit, and I'll bring this up so we can see it. So if I run this section, you can see, maybe I'll stop it for a second so we can just see what's happening. We started with hour 1, and we started with second 0. Now we're going to hang in this loop continuously until we reach 59 on seconds. So if you look for all of these values, I stopped the code in the middle, but we see we have hours is always 1 because the seconds, I guess I shouldn't call it seconds, let me call it minutes. Sorry. Let's call it minutes. Because the minutes are incrementing by 1. So if we do this, now we see they're incrementing by 1. You can see the minutes at the bottom. Hour 1 minute is going up to 59. Once it goes up to 59, we're going to pause because this loop finishes. Now we're paused now. We're here. We're pausing for 5 seconds. Then it's going to loop back up and make hours equal to 2. And now we see we're on hour 2, and we are repeating this inner for loop. So this inner for loop is going and going and going. It has to finish in its entirety before we leave it. And then once it gets to 59, which is the last value in this loop, we'll jump back up and hours will become 3. Because again, we're taking these numbers one at a time. So now it's 3. And we're going to be doing this code on and on and on, repeating every time we run the loop. And then we'll pause for a longer amount of time when it hits 59 to jump back up. And that will be at 4. And that's basically the general idea of how this works conceptually. And this doesn't need to be applied to just 2 statements. Say I wanted to go a little bit more, for hours equals 1 to 12, for minutes is equal to 1 to 60, and for seconds is equal to 1 to 60. Now we're getting crazy because now we have hours, minutes, and seconds. We have 3 for loops that are happening. Do not be overwhelmed by this. It's the same exact logic. Let's do fprnf. We'll say hours is percent I. Maybe I'll put it on one line. Minutes is percent I. Seconds is percent I. And we will put those variables in order: hours, minutes, and seconds. And I'll pause for, again, 0.2. So what is this doing? When we come into this outer loop, hours is set to 1. Now we're in this loop, minutes is set to 1. Now we're here in seconds is set to 1, and then that'll change on each iteration. 1, 2, 3, while the rest of these are fixed. After this finishes, and I guess what we can do again is the 0 to 59 thing. Did the same exact thing again. After we finish the 59 seconds, we'll come up and increment the minute. And we'll repeat the 59 seconds. This is like a real clock, right, in terms of time. It's going to go through 50 or 60 seconds, then it's going to go through 60 minutes, and then ultimately it will change the hour. So let's run this and see what it looks like. Oops. This is what happens if we don't do a \n. I'll do that again just to show you. You can see it's just going like right next to each other, not really ugly and hard to read. So let me do a \n so we can see it better. So if we run, you can see that hours and minutes are fixed and seconds is going up by 1 because this inner loop is going right now. Actually want to pause it again. After this inner loop run, let's pause it for 5 seconds. We'll pause this for 10 seconds. If we even get that far, we'll see how long this takes. But if we go ahead and run, we see that our hours is 1. That's set by this outer loop. Minutes is 0. And now seconds is doing its entire thing before pausing for 5 seconds. That's what's happening now. We'll come back up in minutes and make the minutes go up to 1. Now you look, we see hours is still 1. We haven't gone up to the top of the overall for loop yet. We finished this, we came here, and now we're just iterating here. So really what we're changing right now is this section of the code. We're doing seconds from 0 to 59. Once that finishes, we increment up in a minute. And then after the minutes finish from 0 to 59, we would increment up in the hour. And it's going to take a long time, as you can see. But that's the general idea, because after this finishes, maybe what I'll do for the sake of time, let's say I just make this 58 and say that's what we're starting with, 58. So let's try this again. So now it's saying we're 1 hour and 58 minutes and some amount of seconds. Just going up quickly. Once we finish seconds, we will increment up in the minutes. So we're pausing for 5 seconds. We're here in the code. Come back up to minutes, increment to 59. Go through this entire thing again. This is what's happening right now. We're pausing for 0.2 seconds, which is why it's happening so quickly. Once this hits 59, which it's about to, we'll pause again for 5 seconds. And at this point, the minutes is done. And now we're pausing for 10 seconds. Just for demonstration. Once we're done pausing for 10 seconds, the hours will go up to 2, which is what we'll see probably about now. So now we see 2 hours, and it's starting again with minutes at 58, and then we're going through the seconds. So this is just happening. We're going to finish the 60 seconds, increment up to the next minute. So we'll see this 58 become a 59. It's incrementing, it's incrementing, it's incrementing. Once it is done with this whole thing, meaning we are done with this values here, 58 and 59, we'll then pause for 10 seconds. So what it's going to do now is going to pause for 5, and it's going to pause for another 10, just based on the way the code's written. We will end, come back to the top, and make our hours go to 3. And that is what nested for loops do. And they're extremely useful depending on what you're doing with data analysis or organization of things or modeling to alter variables in different ways. I hope that this video helps conceptualize what's happening, but just always remember, as soon as you encounter a for loop, it has to run in its entirety before you can move on. So this has to run in its entirety before we come and repeat this. Now this minutes thing has to run in its entirety before we come and do this. And then eventually, after a while, we'll get to hours equal to 12. And once that happens, well, then we've completed all of it and we would just end. And we've gone through a 12-hour day, essentially. Okay. I hope that this helps. If you have any questions, please comment or please let me know through Canvas, and I'll be happy to help you. Okay. Thanks for watching. Bye.